Hello everyone, my name is Yijing Liu. I'm from Tsinghua University. Here I'm going to present the work I did with my colleagues on understanding the ecosystem of Chinese ticket grabbing apps. I believe we have all been there rushing to a ticketing platform, clicking buy now for that dream concert ticket, but only to be met with a disappointing sold out message. So who took our ticket? The answer is ticket scalpers, and that is what we are here to talk about today. The root causes of scalping is fundamentally the imbalance of supply and demand. Typically, scalpers snap up a large number of limited resources in advance and then resell them to users at higher price. However, with real name system and various regulations, this method has been heavily restricted. Nowadays, scalpers has turned to a more covered method. They develop a kind of ticket grabbing app that can be operated by users. These apps grab tickets from the target platform on behalf of users, and we call this the user-driven model, which is the main focus of our research. Ticket grabbing apps seriously disrupt the order of market transaction. In our work, we concentrate on this kind of app and try to explore the ecosystem behind this app. We raise our research question from three related parties. First, what technical tricks do developers use to create this app? Second, what security risk do this app pose to users? And lastly, how do this app interact with the target platforms? Given that these apps can be quickly removed or frequently updated, we begin by collecting 20 typical apps from search engines as our seed data, including grabbing app for train tickets, concert or sport event, commodities, and hospital appointment. Then we collaborate with a renowned security vendor in China to enlarge the dataset using keywords. Then, with a combination of static and dramatic analysis, we uncover the technical features of this app. We also conducted an online survey involving 184 participants to gauge the social characteristics of the apps and understand participants' privacy concern. Following, we systematically address our research question and show some interesting findings. First and foremost, we want to understand how this app works. Based on the analysis result, we identified two distinct ways for grabbing tickets. Some apps use high-performance server as an intermediary and repeatedly submit purchase requests to the target platform. In this way, ticket grabbing apps just serve as an information collector. Another kind of app do not have servers, and they use Android accessibility server to simulate click and directly submit purchase requests to target platform from users' devices. Accessibility server is an inherent Android feature for users with disabilities. Unfortunately, it has been widely used in underground industry in recent years. Now let's take a typical commodity grabbing app as an example. To improve efficiency, this app always implements various tricks. Most of them provide integrated support for multiple platforms within one single app and do time synchronization to determine the network delay. Users can personalize the start time, duration, and frequency of the grabbing process. Additionally, this app offers different grabbing methods, including the BP link, this means bypass link, which directly take users to the order submission page by passing the parameter selection process. Instead of profiting through resale, ticket grabbing app make money by selling users the ability to secure tickets and make money through usage. The free version typically offers a trial period, and after which users need to pay for a license key to continue. Also, some apps offer paid servers like acceleration package, claiming to increase the success rate of ticket purchase. However, no app guarantees a 100% success rate. In our survey, only a few participants reported being successful in every attempt, and most participants still failed even after payment. Next, let's look at the findings from the user's perspective. According to our results, nearly half of the users said they had used ticket grabbing apps. basically for buying train or concert ticket. Most users download this app from official app store, while others obtain them from social media and search engines, which often lack proper scrutiny. Our research focused on the security risk of ticket grabbing app posts on users. Using Android Guard, we discovered that each app requires on average more than 80 permissions. Compared with benign app, ticket grabbing app ask for more sensitive permission and related to their primary function. Additionally, over half of the app would request a root privilege, giving them the highest level of control over the device. With root access, app can active accessibility servers without users' confirmation. Regarding privacy risk, while most ticket grabbing apps lack privacy policies, but this doesn't mean they do not collect any information. During the simulated run, we found that some apps collect the login credential of the target platform and even the payment password to facilitate the grabbing process. Moreover, we found that two apps may capture screenshots and upload them to remote servers, making the app transformed into a spyware. Given the above security and privacy risk, we employ the 5-point Likert scale method to assess the level of users' privacy concern. We released that more than half of the participants were aware of the privacy risk posed by ticket grabbing app. However, due to the pressing need for tickets, the majority of users continue to use them and willing to provide their personal information during usage as they prioritize tickets over privacy. Last, apart from the target platform, platforms are motivated to protect their users and maintain a fair ecosystem. Meanwhile, developers of ticket grabbing apps persistently seek ways to evade detection, resulting in an ongoing tension. Even though ticket platforms develop robust detection systems like IP-based interception, anomalous behaviors detection, and capture verification, ticket grabbing apps remain active in the market. So we summarize the various bypass skills they use, including using multiple IP proxies to switch source IP, using accessibility server to simulate normal users' behaviors, and embedding some capture solve API to automatically identify the capture. So we can see that ticket grabbing apps rely on a series of tools to perform their function and bypass system, including these legal and illegal servers. Therefore, these tools become the bottleneck of ticket grabbing app. So we propose an indirect combat method to intercept this app by posing restrictions on these bottlenecks. More specifically, for legitimate servers, we recommend that this server provider should conduct a more stringent review on the purpose of the object to be served to avoid supporting malicious application. For inherent malicious servers, we should crack down and completely eliminate the server provider using some national measurement. For example, a unified reporting interface is required for users to report servers found to be used in the illegal industry. Finally, it is also essential to enhance the review process of app market to prevent the releasing of such app, and our publicly available dataset can serve as a reference for app markets. So in summary, we take the first step towards analysis of ticket grabbing app ecosystem, which is a rapidly developing underground industry. And our work released for the first time the security and the privacy risk posed by ticket grabbing app and obtain users' usage and privacy concern about the apps. We put forward an indirect combat approach and 3 specific suggestions that could indirectly crack down on the emergency of ticket grabbing apps. And that's all. Thanks for listening.